After analyzing in frequency domain using continuous time Fourier transform, and we concluded that omega s must be greater than or equal to 2 times of omega m. Okay, so omega m represents maximum frequency content in the source signal. So sampling frequency must be taken greater than or equal to 2 times of omega m, or fs must be greater than or equal to 2 times of fm. So this is called the sampling theorem or Nyquist sample rate. Okay, if we maintain the sampling frequency fs less than 2 fm, there will be the overlapping of spectrum. We cannot able to recover our original signal back from the sampled information. This is what we concluded in the previous lecture. So today we'll discuss some problems related with the sampling theorem. In Unit 5, this topic is very important, theory as well as problems. Problem number one. Problem number one. A signal having a spectrum ranging from near DC to 10 kilohertz, near DC to 10 kilohertz, is to be sampled and converted to discrete form. What is the minimum number of sample per second that must be taken to ensure recovery? A signal is there. There are different frequency content available, meaning they mix with combination of some signals. So the frequency content varies from DC to up to 10 kilohertz. So we need to take the sample of the signal or convert into discrete form. Again, at the receiver side, if you want to convert into original information, analog information, without any loss, what is the sample rate? Okay. What is the sample rate? The simple questions. So solution. Solution. FM. That is the given maximum frequency content of the signal. 10 kilohertz. 10 kilohertz. From Nyquist sample rate. From Nyquist sample rate, the minimum number of sample per second. The minimum number of samples per second. Minimum number of samples per second that must be taken to 20 kilohertz, otherwise 20,000 samples per second. Fs must be 20,000 sample per second. Okay, this is called a sampling rate. Otherwise, it is called as sampling rate. Sampling rate. How many samples we are taking per second? That is called a sampling rate. Okay, this way you have to solve the problem. Basic problem it is. Suppose example 2. Example 2. X of t equal to 10 sine of 100 pi t plus 10 cos of 200 pi t plus 20 cos of 300 pi t. Okay. Now tell me, what is the sampling frequency? What is the sampling frequency? So that we can recover the original information back without any loss. In this case, how to solve the problem? What is FM represent? What is FM, 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 FM,
Maximum frequency.
Maximum frequency content. So first we have to find maximum frequency content. You know the standard format of sine representation, cos representation, A sine omega naught t or A cos omega naught t. So this is your omega. So here 10 pi, 200 pi, 300 pi. So first section, first section, omega 1 equal to 100 pi. Okay, omega equal to 2 pi f, 2 pi f equal to 100 pi. So f1, fn equal to pi will be cancelled, f1 equal to 50 hertz. Next section 2, second section, let's say omega 2 equal to 200 pi. So 2 pi f2 equal to 200 pi. Pi will be cancelled. So f2 equal to, you will get 100 hertz. Next, third signal. Let's say omega 3 equal to 300 pi. 300 pi. 2 pi f3 equal to 300 pi. Pi will be cancelled. So we will get f3 equal to 150 hertz. So what is it? Don't assume this is the frequency of a signal. Standard format of sine cos representation A sine omega naught t. A sine omega naught t. So you compare the coefficient of t, that is omega naught. From the omega naught, we have to find out frequency. So 50 hertz, 100 hertz, 150 hertz. So maximum frequency, that is maximum frequency is 150 hertz. Maximum frequency is 150 hertz. Therefore, the sampling frequency must be greater than or equal to 2 times of fm. So 2 times of 150, 2 times of 150, that is 300 hertz. Fs is 300 hertz. Ts, Ts equal to 1 by Fs. So 1 divided by 300 hertz. Ts equal to 1 divided by 300 hertz. About 10, 11, 0, 0, okay, 1000, like this. Second. Okay. The sample, sorry, I think this is the sampling rate actually. Sampling rate. Ts. Ts represents sampling rate. Fs sampling frequency. Fs sampling frequency. Okay. So for all the problems, if they're asking to find out number of samples per second or sampling frequency or sampling rate, it's better you do it everything. Find out maximum frequency content. How to find maximum frequency content? You have to compare with your standards sine cos format and calculate individual frequency and check which one is highest frequency component, that you have to consider as your maximum frequency content. Then 2 times of fm, you will get 300 hertz. Okay. So this is the sampling frequency. This is sampling frequency. This is sampling rate. Yes, this is sampling rate. This is second kind of problem. This problem I just given the example for you. Okay. Next one. Suppose 10 sine square 200 pi t. Find the sample rate. How to perform this? How to do it? X of t equal to 10 sine square 200 pi t.
1 minus cos 2t.
Yes. So you should not calculate the frequency directly. Always you have to convert your expression in terms of sine t cos t only. Suppose sine A sine B given, cos A cos B or any combination, then you apply the trigonometric formula and convert into individual sine component and cosine component. So sine square theta 1 minus cos 2 theta divided by 2. So 1 minus, this is constant, 1 minus cos 2 theta divided by, okay, so 10 by 2, 5, 1 minus cos 400 pi t, or you can represent 5 minus 5 cos 400 pi t. Now cos omega naught t, this is a DC component, no need to worry about that. Cos omega naught t, this is similar to a cos omega naught t, this is similar to a cos omega naught t. So only one frequency component is there. So you can directly find out omega m equal to 400 pi. 2 pi fm equal to 400 pi. Pi will be cancelled. This is 200. So fm equal to 200 hertz. fm equal to 200 hertz. So as per the Nyquist sample rate, the minimum number of samples frequency fs should be greater than or equal to 2 times of fm. So therefore 2 into 2, 400 hertz. 400 hertz. Sample rate Ts equal to 1 by 400 second. Sample rate, sampling frequency. Okay. Sin square theta, cos square theta, sin A cos A, sin A cos B, whatever may be the combination, we have to convert into individual sine component, cosine component, and then compare with the standard format, find out your Fm and Fs greater than or equal to 2F. This is another kind of problem. So like this, I could see many examples, same pattern, nothing differences, but whatever coefficient of t, the entire term you have to consider as your omega. Okay. Any doubt in the simple problem? Next, we will go another level problem for drawing the magnitude spectrum. Are you clear with this simple problem in sampling? Semester paper, I'll post the semester paper. You try to solve more problems. I'll give an assignment from sampling theorem problem. Shall we move ahead? Next problem.
Yes, sir.
Yes, sir.
So this is somewhat advanced problem. The signal x of t, the signal x of t equal to 10 cos of 10 pi t is sampled at a rate of 8 samples per second. 8 samples per second. Plot the amplitude spectrum. Plot the amplitude spectrum or magnitude spectrum for omega less than or equal to 30 pi. Next questions. Can original signal be recovered from sample? Explain. This is somewhat advanced level problem, but very simple one. Okay. What are the questions? Now, first 3 problems, we found what is the sampling rate, minimum sampling rate, so that the signal recovery is possible. Okay. Now, in these questions, they given the sampling rate. What is the sampling rate they are taken? Now, we have to conclude from the sample whether original information can be reconstructed. Is it possible? And moreover, we need to draw the magnitude spectrum for omega less than 35, meaning right side 35, left side minus 35. Because the spectrum available from minus infinite to infinite, so we cannot draw it. So we have to draw from minus 35 to plus 35, right? So how to proceed this solution? remember the continuous time Fourier transform of sine t, cos omega t, sin omega naught t in unit 3. So x of t equal to 10 cos 10 pi t. Okay. Fourier transform of x of t equal to 10 pi del of omega plus 10 pi plus del of omega minus 10 pi. So this is the Fourier transform of 10 cos pi t. Please check your unit 3 how to find the continuous time Fourier transform of cos omega naught t sin omega naught t. So this problem we already solved in CTFT. Please check CTFT in unit 3. Okay. Sin omega naught t pi del of omega plus 10 omega plus omega minus 10 omega. So can we draw the spectrum now? You have to remember the formula in yesterday class. So where I left,
Formula, sir. Excess of j omega.
x of t equal to 10 cos 10 pi t sampled at the rate of 10 samples per second. We need to plot magnitude spectrum and we have to check whether signal can be recovered or not. Okay. As per the problem statement, fs equal to 8 hertz. As per the problem statement, fs equal to 8 hertz. Okay. So fs equal to 8 hertz meaning omega s equal to 2 pi fs. So 2 pi 8 equal to 16 pi. Okay. So this is as per the statement. This is as per the statement. Omega s equal to 16 pi, because in the formula we have omega s now. The formula we have omega s. So I will use the same symbol. To draw the magnitude spectrum, we need the omega s value. So according to the given problem statement, omega s we found. Next, x of t equal to 10 cos 10 pi t. X of t equal to 10 cos 10 pi t. So as per the Nyquist sample rate, as per the Nyquist sample rate, as per the Nyquist sample rate, omega m equal to 10 pi. Omega m equal to 10 pi. That is 2 pi fm equal to 10 pi. So pi will be cancelled. Fm equal to 5 hertz. And the sampling frequency is greater than or equal to 2 times of fm. So 2 into 5, 10 hertz. As per the Nyquist sample rate, as per the Nyquist sample rate, as per the Nyquist sample rate, therefore, Fs must be 10 hertz. Fs must be 10 hertz to recover original information. To recover original information. Okay. But what is the sample rate they have taken? 8 samples per second. 8 samples per second. So in the given problem, the given problem statement, the Fs is less than the Nyquist sample rate. So the signal cannot be recovered or recoverable. Okay. They're asking what they are asking in the problem. Can original signal be recovered from sample? Explain. No. As per our statement, as per the given problem statement, Fs 8 hertz only. Fs is 8 hertz only. While calculating Nyquist sample rate, Fs must be minimum of 10 hertz. Maximum whatever it may be, minimum of 10 hertz. So therefore, the original information cannot be recovered. So one part is completed. Next, we have to draw the magnitude spectrum. The magnitude spectrum of the signal. Excess of j omega equal to. Look at this. Excess of j omega equal to 1 by t. Because 10 cos 10 pi t. This is our actual information which we are going to take this sampling. We are applying the sampling process. So CTFT of this x of t. CTFT of the continuous time signal 10 cos pi t. This is the result. As per the sampling theorem, we have derived the formula yesterday. Xs of j omega equal to 1 by Ts, Xc of j omega minus k omega s. Okay. So what is 1 by Ts? Plot the amplitude spectrum for their given value, not our calculated value. Whatever the sample rate they given, for that sample rate we have to plot the magnitude spectrum. Okay. To draw the magnitude spectrum. To draw the magnitude spectrum. To draw the magnitude spectrum. So excess of j omega equal to 1 by Ts summation k equal to minus infinite to infinite xc of j omega minus k omega s. So what are the information we needed now? Xc of j omega. Okay, that we got it already. Next Ts, next omega s. So omega s we calculated already. Omega s we calculated already. This is our omega s. Ts. If you want Ts, Ts equal to 1 by Fs. Ts equal to 1 by Fs. So 1 by 8 second. Ts equal to 1 by 8 second. Okay. Now can we apply all the xc of j omega, Ts, omega s value in the formula? So excess of j omega equal to 1 by t, 1 by t, 1 by Ts. Summation k varies from minus infinite to infinite. 10 pi del of omega plus omega plus 10 pi minus k omega s. Okay. Plus pi del of omega minus 10 pi minus k omega s. Okay. So xc of j omega 10 pi del of omega plus 10 pi plus omega minus 10 pi minus k omega s. We have to add minus k omega s in each and every term. That's it. Minus k omega s we have to add each and every term. So now substitute omega s value and Ts value. Now substitute omega s value and Ts value. Excess of j omega. 1 by Ts value 1 by t. T equal to 1 by 8. T equal to 1 by 8. So 1 by T is 8. 8 into 10, 80. 80 pi. Take this pi outside. K equal to minus infinite to infinite. Del of omega plus 10 pi minus 16 k pi. Okay. Omega s value as per the given sample rate. As per the given sample rate. What is omega s? 16 pi. So 16 pi. 16 k pi. Next. Plus del of omega minus 10 pi minus 16 k pi. That's it. So now in this formula, if you substitute k equal to 0, k equal to 1, k equal to 2, then we can draw the magnitude spectrum. Okay. So to draw the magnitude spectrum for the given sample rate or our sample rate as per Nyquist sample rate, we need this excess of j omega expressions. Prior to that, we must know the CTFT of cos omega naught t, CTFT of sin omega naught t. This all problem is solved in unit 3. Please recall your class notes. And then calculate your Ts, omega s, and rearrange your equation like this. Okay. Now we can draw the magnitude spectrum. How to draw the magnitude spectrum? Omega. Okay, omega. Excess of j omega. omega excess of j omega. Okay. 0 algebra. Substitute k equal to 0. K equal to 0. This term will be cancelled. This term will be cancelled. So del of omega plus 10 pi. Del of omega plus 10 pi. So where to draw del of omega plus 10 pi?
Left side.
Left side. This magnitude is 80 pi. Magnitude is 80 pi. Next, del of omega minus 10 pi. Del of omega minus delayed version of your del function. Over. So one set is over. Substitute k equal to 1. Substitute k equal to 1. Substitute k equal to 1. What do you get? We substitute
Minus 6 pi.
for k equal to 1, excess of j omega equal to 80 pi del of k equal to 1. 16 minus 16. Minus 16 pi plus 10 pi. So del of omega 16 minus 10 minus 6. Okay. First term. Del of omega. Correct now. Minus 6 pi. This side del of k equal to 1. So minus 16 minus 10. You will get minus 26. Del of omega minus 26 pi. So this is the expression at k equal to pi. So can we sketch this? Del of omega minus 16 pi. 6 pi. Omega minus 6 pi. Let's say assume this is 6 pi. Okay. Next omega minus 26 pi. Let's say assume this is 26 pi. Substitute k equal to minus 1. Or if you try to plot k equal to 2, go for k equal to 2. Go for k equal to 2. What is your expression? You substitute k equal to 2. 2 into 16, 32. 32 minus 10, 22. So no problem. This is less than 30 pi only. And if you substitute k equal to 2, 32. 32 plus 10, 42. But in the problem, what they are asking, plot the magnitude spectrum omega less than or equal to 30 pi. Okay. So no need to go for k equal to 2. K0, K1 fine. Now substitute k equal to minus 1. Substitute k equal to minus 1. What you will get? Substitute k equal to minus 1. For k equal to minus 1, your excess of j omega equal to del of omega minus into minus plus. So 16 pi. Sorry. 26 pi. 26 pi plus del of omega minus into minus plus. Okay. 16 plus 16 minus 10 plus 16 minus 10. So you will get plus 6 pi. Correct or not? K minus 1 minus into minus plus 16. 16 plus 10, 26. K equal to minus into minus plus 16 minus 10 plus 16 minus 10. So you'll get omega plus 16. Now plot this. How to plot it? Omega plus 6 pi. Where to plot? Signal started in advance. Plus meaning signal started in advance. Next, omega plus 26 pi. Let's say for example this is 26 pi. So this is the magnitude spectrum of the sampled signal as per the given sample rate. This is not Nyquist sample rate. As per the given sample rate, if we try to plot, this is the magnitude spectrum. Okay. See, this is one set of component. This is one set of component, and these two another set of component, and these two another set of component. So all the frequency components are merged together, overlapped together. So if you try to design any kind of filters, if you try to plot any kind of filters, you cannot able to recover our original information. What is our original information? That you should to plot first. What is our original magnitude spectrum? What is the magnitude spectrum of original signal? That is xc of t equal to 10 cos 10 pi t. So excess of j omega 10 pi del of omega plus 10 pi plus del of omega minus 10 pi. So actual plot, actual information, xc of j omega is omega versus xc of j omega, pi del of omega plus omega pi, and pi del of omega minus. So 10 pi and minus 10 pi with the magnitude of 10 pi. So this is actual information. This is actual information. Understanding, no? X of t. This signal is a continuous time signal. We are taking the sample of this particular signal. Okay. So draw the magnitude spectrum of this original signal. After finding Ct of t, if you sketch spectrum of this 10 cos 10 pi t, pi del of omega plus 10 pi, this component, del of omega minus 10 pi, this component, with the magnitude of 10 pi, This is the actual information. Is it possible to recover this information from the given sample rate? As per the Nyquist sample rate, we already stated it is not possible. So once again, we are going to prove it in terms of magnitude spectrum. See here, we need this component. So if we design a filter, like this, can we get our information only? Can we get our information alone? No. So this is another spectrum, another set of spectrum component available here, another set of spectrum component. So the spectrums are overlapped with the neighbor spectrum. Individual, each and every frequency spectrum overlapped with the other spectrum. So it is not possible to recover our actual information. This is our actual information. This is our actual information as per the given x of t. As per the given x of t, this is our actual information. So this information cannot able to recover from the sample rate fs is 8 Hz. They given fs is 8 Hz. If you proceed fs is 8 Hz, then try to plot your magnitude spectrum. It is not at all possible to recover your original signal. So once again, you have to write down the conclusion. Okay. From the magnitude spectrum, it is not possible. It is not possible. It is not possible to recover original spectrum. Okay, so this is the conclusion of this problem. All problems are easy only, but small things you have to remember. That's why CTFT first. That's why CTFT first. Before start of the sampling theorem or sampling process, we must study continuous time Fourier transform. Okay, then only it is possible. So, or maximum possible problem pattern is like this one. Simple problem they will ask. Second possible, more than one signal will be given. Third one, sine square theta or cos square theta or sine A, sine B, cos A, cos B, in that format. And then general format. They will give some signal. They provided their own sample rate, and we need to plot amplitude spectrum for their specification. And we have to derive our sample rate as per the Nyquist sample rate and give some conclusion. Okay. Now, one more problem type is available, that is in terms of sinc pulse. Suppose sinusoidal, cosine, no problem. Suppose sinc function given, how to solve it? That we will discuss in next lecture after the holidays. So, any doubt? Please practice these problems, very important, and be clear with that. Don't feel this very difficult. It's very simple only. Once again, you repeat this video lecture and listen carefully and how to draw the spectrum by substituting k0, 1, 2, -1. I have stopped at magnitude spectrum k0, k1, k-1 only. Why? Why not k equal to 2? In the problem given, draw the spectrum modulus of omega less than or equal to 30 pi. Less than or equal to 30 pi. If I substitute k equal to 2, I am getting more than 30 pi. K equal to -2 also, I will get more than -30 pi component. So we can stop. Draw only these three component spectrum. K equal to 0 spectrum, K equal to 1 spectrum, K equal to -1 spectrum. Okay, that's why I stopped with these three spectrum. So signal sketching, how to sketch the signal, you must have that knowledge. And the CTFT of sine omega naught t, cos omega naught t, you must have that knowledge. And how to find omega s ts in the formula. How to find omega s value ts value. That you have to know. Finally, you can able to draw the spectrum. Otherwise, it's not possible. Okay. So, any doubt, please ask me. I'll help you. Next class, we will solve sinc function related problems in sampling. I'll give some assignment today. Evening, I will post problems related with the sampling theory from the semester paper.